Okay, in this video, I will explain you the very important concept, that is the design of gauges. So, in that design of gauges, initially to make a maximum extent, to make a maximum extent, each gauge is a uh, each gauge is a copy of what is a copy of the component which mates the which mates with the component for copy of the component which mates with the component for which the gauge is manufactured. The component for which gauge is manufactured. Nothing but what? To a maximum extent, how the gauge is to design of gauges. First, initially, for maximum extent, gauge is a copy of component which mates with the component for which the gauge is manufacturing. That is the first important, very important one. Next, the gauge is designed as an exact copy of the opposite component of which the dimension has to be checked. So same as I will explain the classification. I told you the concept of this one. The gauges are designed as an exact copy of the opposite components of the same dimension. For the same dimension has to be checked. Nothing but what? Standard gauges. Standard gauges. This is also very important one. And in the design of gauges, the simplicity of gauges must be the main aim, as the simple gauges can be used for continuous measurement with accuracy. So other than the standard gauge, we are using a limit gauges, that we already know that. So by keeping this in mind, design of gauges, the very important concept is what? Work allowance and gauge allowance. I forgot to write this here. Gauge allowance and the work allowance is very important. So work allowance is nothing but what? It is the difference between the upper limit and the lower limit of the shaft or hole. In the earlier we are used right here. This is what the upper limit. This is what the lower limit. So upper limit minus lower limit. So difference between the upper limit minus lower limit will be the work allowance. Work allowance. Okay. So this is nothing but a difference between. First, and it is necessary to specify the permissible deviation in the dimension for a gauge manufacturing. It is necessary for the work allowance should be, it is necessary to specify the permissible deviation in dimension for gauge manufacturing. In regarding all these work allowance, and one more concept, the tolerance on the gauge is allowed. So the tolerance on gauge is also allowed to cater for the degree of skill, for the degree of skill with which the gauge is manufacturing, gauge is being manufactured. So this concept, concept we can call as a what? Gauge tolerance or gauge maker tolerance. This is very important. Work allowance is nothing but what? Difference between the upper limit and the lower limit of the shaft or hole, and it is necessary to specify the permissible deviation, and the tolerance on gauge is allowed to cater for the degree of skill with which the gauge is being manufactured. This concept we can call as a what? Gauge maker tolerance, or another name of gauge maker tolerance or gauge allowance. It is taken as what? 10% of the work tolerance. I have already told you, right? Gauge allowance is what? 10% of the work tolerance. I have mentioned here. See here in the figure I have mentioned. So 10% nothing but what? So that divided by 10% of the this one. With respect to what? X divided by 10 we have taken upper limit minus lower distance, tolerant distance with respect to 10. That we can call as a what? Work tolerance. That is 10%. That is a gauge tolerance nothing but what? 10% of the work tolerance. So see, this is regarding the work allowance and the gauge gauge tolerance. Now another important concept is what? Wear allowance. In the wear allowance, I already shown in the previous figure. See here in this figure again I am telling you, for the here for the plug gauges can be used for hole, and the ring gauges can be used for shaft. Another name for ring gauge is what? Snap gauges. So snap gauges. So and here this is the lower limit and this is upper limit. So in this one the go gauge will be come under the lower limit, and for the upper gauge it will come under the upper limit. No go gauge will come under the upper limit. So here in the go gauges are continuously rub over the surface. I already told you in the initial figure. And so the go gauge will always rub over the surface of the job. So to be inspected, which leads to what? Which leads to wear of the go gauge surface and reduction in the initial size. That can be happened in the wear allowance. That can be happened. So that happened in the go gauges. Hence there is no need to provide a and hence there is a need to provide. There is need to provide the wear allowance on what? Go gauges. Provide on why we need to provide a wear allowance here? It is continuously rub over the surface of the job, and job nothing but workpiece to be inspected, which leads to a what? Wear of the go gauge surface and reduction in the initial size. So for that reason we need to provide a wear allowance on the go gauge. So for that reason only we have mentioned here. See here we are allow the wear allowance on the go gauge side. Wherever the go gauge side is there we are leaving the wear allowance. This is the general ISO, that is International Organization for Standard type. It is a combination of both workshop and the inspection. It is a combination of inspection and wear allowance we have maintained here. Here we are taken from the workshop gauge. Combination of workshop and the inspection. Here also same inspection and the workshop. Ring gauges, go gauge will be in the upper limit and no go gauge will be in the lower limit. See, and also adding wear allowance to the gauges, it will help to increase the life of the gauges. Adding what? Adding wear allowance leads to what? Increase in the life of the gauges. The life of the gauges. Okay, and for as per the British standards, wear allowance is applied when the work tolerance is greater than the 0.